All right, this is Chapter 5, Lesson 5, Simplify Algebraic Expressions. So, identify parts of expression. When addition or subtraction signs separate an algebraic expression into parts, each part is called a blank. So in that blank, you're going to write term. So when addition or subtraction signs separate an algebraic expression into parts, each part is called a term. Recall that the numerical factor of a term that contains a variable is called the blank of the variable. In that blank, you're going to write coefficient. So the numerical factor of a term that contains a variable is called the coefficient of the variable. Blank blank contain the same variables to the same powers. For example, 3x squared and negative 7x squared are like terms. In that blank, those two blanks you're going to write like terms. So like terms contain the same variables to the same powers. For example, 3x squared and negative 7x squared are called like terms. So are 8xy squared and 12xy squared. Okay, notice they have the same variables, raised to the same power. X and y, and then the 2 is attached to the y. Okay? But 10x squared z and 22xz squared are not like terms. Notice that 10x squared, I don't have an x squared here, so that means they're not like terms. A term without a variable is called a blank. In that blank, you're writing constant. Term without a variable is called a constant. Constant terms are also like terms. All right, so if I have 3 terms, I have negative 4x plus 12 plus x. Okay? The negative 4x and the x are like terms. Okay? So each one of these is a term. Okay, there's 3. They're separated by a plus sign. And 12 is my only constant. Okay. I can also note that negative 4 is a coefficient. So negative 4 is my coefficient. There is technically a coefficient of 1 in front of the x. So if I'm identifying the terms, like terms, coefficients, and constants in the expression 6n minus 7n minus 4 plus n. So to start with, all right, so if I'm identifying the terms, like terms, coefficients, and constants in the expression 6n minus 7n minus 4 plus n. So this is actually where it's super helpful to have markers that are different colors or different colored pencils or whatever the case may be. So I can rewrite the expression 6n plus negative 7n. Okay, so I'm just adding this, I'm just changing the negatives, the minus, the subtraction signs to positives, plus negative 4n plus n. Okay, this reminds me and lets me know, okay, 4 is actually a negative number. 7 is actually a negative number. Because I can rewrite any subtraction as negative integers. Okay? So terms are 6n, negative 7n, negative 4, and n. So anywhere I see that plus sign, that's where those are each of my terms. Okay? Like terms, in this case, 6n, negative 7n, and n. Those are my like terms. They're together. Okay, they all have an n attached to them. My coefficients, so anything in front of a variable, 6, negative 7. Okay? And technically 1 because there's a 1 in front of the n. And then my constants, anything without a variable attached, negative 4. Okay? So I can actually go through and mark, so I can say, okay, orange is going to be where my terms are, and I can highlight them in orange. You know, yellow is going to be where my like terms are. I can highlight them in yellow. However you want to do it to make your life easier. You can box terms, you can box coefficients, things like that, all right? So then I can write, the next thing I want to do is be able to write 4y plus y in simplest form. So 4y and y are like terms. If they weren't like terms, I could not simplify them, okay? They're like terms, so I can simplify them. So 4y plus y is really like saying I have 4 of them, and I'm adding 1 more. So I have 5 total y's. So 4y plus y, 4y plus 1y. Remember that 1's that invisible 1 in front. Okay, so 4 plus 1 is 5, so I have 5 y's. Okay. You can also kind of think of it as like M&Ms. I have 4 M&Ms plus an M&M, so I have 5 M&Ms total. All right? The cost of a jacket J after a 5% markup can be represented by the expression J plus 0.05J. Simplify the expression, then determine the total cost of the jacket after the markup if the original price is $35. So we've got a couple of steps that we want to do. So when I'm doing this, J plus 0.05J is really like saying 1J plus 0.05J. We can say that because the identity property J equals 1J. Okay, that's the identity property. So this equals 1 plus 0.055 times J, which is the distributive property. All I did was I took out my coefficients and put J on the end because they're both J. I can simplify. 1 plus 0.05 is 1.05. So that's my simplified expression. I did the first part. Now I want to know if the cost of the jacket after the markup, the original price is $35. So I substitute in $35 for my J because that's the cost of the jacket. $1.05 times 35 gives me $36.75. So the cost of the jacket after a 5% markup is $36.75. All right, if I'm simplifying algebraic expressions, an algebraic expression is in blank blank if it has no like terms and no parentheses. So in those blanks, you're going to write simplest form. So an algebraic expression is in simplest form if it has no like terms and no parentheses. Use the distributive property to combine like terms. All right, there are a couple of try it problems. I want you to go ahead, pause the video, try them out, and when you're done, we'll go over the answers together. All right, now that you've had a chance to try out the try it problems, let's go over the answers together. So the first one I have says identify the terms, like terms, coefficients, and constants in the expression. So I'm going to go ahead and color code these. So terms are going to be blue. Like terms are going to be orange. Coefficients are going to be purple. And constants are going to be pink. All right. So my terms, first I'm going to rewrite this so I have only addition. So I have 9y plus negative 4 plus negative 11y plus 7. Okay, so now I have all addition. So my terms are going to be in blue. So terms. Okay, so my terms are 9y, negative 4, negative 11y, and 7. My like terms are in orange. Okay, so I actually have two sets of like terms. I have 9y, so 9y and negative 11y. They're one set of like terms. And then negative 4 and 7 are my other set of like terms. Okay, so I have two sets of like terms. My coefficients are in purple. Okay, coefficients are anything in front of a variable. So I have 9y, so 9 is a coefficient. And then negative 11y, so negative 11 is a coefficient. And then my constants are in pink. Okay, constants are anything without a variable, so negative 4 and 7. my next one says write 6 minus 3n plus 3n in simplest form. So I'm looking for my like terms. So negative 3n and positive 3n are my like terms. So if I subtract negative 3 plus 3, that gives me 0. Okay, so I'm just left with 6. So when I simplify this, I just get 6. All right, my last one says, write an expression in simplest form for the cost of the jacket J if a markup is 8%. Then determine the total cost after the markup. The original price of the jacket is $35. So I'm going to rewrite an expression, right? So it's J plus 0.08 J, right? So it's the jacket plus the markup of 8%. So 8% I can change to a decimal, which gives me 0.08. So then I can add 1 plus 0.08, 1J plus 0.08 is 1.08J. And then I need to substitute in 35 for J. So 1.08 times 35 gives me $37.80. $37.80. And that is the end of Chapter 5, Lesson 5.